Okay, as we said, the daily demand is the annual demand divided by how many days per year. So we have daily demand of 400,000 divided by 400,000 divided by 250. So this will give us 1600. Production, we have production rate here, 4,000. Desired EOQ, economic order quantities, 400. We are given the setup cost, $2, $20. Here, we are given the hourly labor rate, which is $30 per hour. So in this case, we are given the Q, we are given the D, we are given the holding cost, the daily demand, the production rate, and we need to find the sit-up time. Of course, if you are rearrange this equation, you square both sides, and then you divide by this term, and then you divide by 2ds, you will end up with this term here, which is qp square times h, 1 minus d over p divided by 2d. So the qp or EQ, which is also already EOQ, which is 400 square. 400 square. This is 400 square. Okay. H is given, holding cost 20 times 1 minus the daily demand 1600 divided by the production rate, which is given here 4,000. So now divided by 2 times the annual demand. So you will get the sit-up time in terms of dollar. You need to change this to minutes. Okay, how? So it is equal to $2.4. Okay, the $30, the 1 hour is equal to $30. Okay, so I divide this amount by the hourly labor rate. So our hourly labor rate is 30. So 2.4, again, 2.4 divided by, let me do it here, 2.4 divided by 30. So you will have 0.08 hours. Okay, what's 0.08 hour? 0.08 hour, use your calculator. If you have calculator, you should have calculator. Let me get my calculator here. 0.08 times 60, which is 4.8 minutes. Okay. Look at this again and try to understand it. How we changed the dollar to minutes. Questions about this?
No.
No. So the idea here, we calculate the sit-up time from the given information. In chapter 12, we used to calculate EOQ, the desired equivalent order quality or the desired order quantity. Usually, we should be given the annual demand. We calculate the daily demand by dividing the daily demand divided by 250. Okay, let me ask one question. What's this 250? Where this 250 came from? You can answer, you can use the chat box if you know what the 250 came from. Where's the 250 came from? Since we already covered chapter 12, you should know where's the 250. Hello, what is the 250? The 250 is 50 times 5, right? Who knows where the 250 came from? We have 15 students.
Say that again, Professor.
So we said that the annual demand is 400,000. The daily demand is 400,000 divided by 250. Where's the 250 came from? It's the number of days, right?
Yeah.
Yeah, you don't need to think about it. How many days per year? 365. But we divide by 250, we said in chapter 12, usually you have 250 working days. That's why we use 250. And usually it's given. If it's not given, you use 250. Okay?
Okay.
So high setup cost encourage large lot sizes. So the goal is, as I gave you one example last time, like we visited a facility, the setup time for one of the devices was 1 week. So, and they have to keep it running, and this cost them like hundreds of thousands of dollars because, you know, they cannot turn it off, because if they turn that device off, and this will cost them lots of money. And, you know, so because it requires 1 week to be set up. Set up time can be reduced through preparation prior to the shutdown and change over. Reducing the setup time, initial setup, for example, separate setup into preparation and actual setup, doing as much as possible while the machine process is operating. Yeah, these like ways to reduce the setup. It depends on the situation and the machine. And, you know, sometimes there's no way to reduce the setup time. Sometimes it can be reduced. Okay, it depends, but these are some ways or tools to reduce the setup cost. There should be a schedule. So schedule must be communicated inside and outside the organization. Kanban signal used in pull system. We said we are using pull system. I noticed that when we have online, like many students, they attend the class than the face-to-face. I have here, I see probably 17 students. But when we were in the class, we had only 4 students. Anyway, so the goal is just you to understand the material. So it doesn't matter if it is Zoom or face-to-face. Signals used in pull system. We said we have pull system. You know, you should be familiar with these terms now. We have pull and we have push. So the pull, the customer pulls. Okay, the customer pull, and then after the customer order, they make or they replace. If they don't make, if they have inventory, they replace it. Okay. But push, they make to order. Mass production. That's the difference between these two. Better scheduling, improve performance, use Kanban, communicate schedules, freeze part of schedule, perform to schedule, eliminate waste. These are uh, scheduling small lots, just in time material. This is an example here. These are small lots. It's easier to reduce the cost and the inventory and find or reduce variability when you have smaller lots. Kanban. Kanban is the Japanese word for card. The card is an authorization for the next container of material to be produced. Okay, a sequence of Kanbans pulls material through the, like, imagine, look at the picture here. What's this picture? It's a drive-through, right? It's a
Yeah,
drive-through.
drive-through.
Yeah,
Fast
imagine like it's the easiest way to understand Kanban. Like when you go to the drive-through, you place the order. So they type the order like before they used to type it before they start using the computer. They used to type it on a card and send it to the one who prepared the meal. But now they do it on the computer. It's similar to the card. So they send a signal to those inside the kitchen to make this meal for you. That's Kanban. Okay? It's CARD, organic card authorization for the next container of material. Imagine that in manufacturing facility, oh, you ordered computer, for example, and they are using Kanban. So the time that you order the computer and make the payment, they start making the meal or the computer. It's the same. Okay. It uses signal. Oh, the signal
Okay.
could be, yeah, the signal here, signal marker. They use also signal marker. I used to work in the industry. I know they use this, for example, like to know the level of the stock or the material they have. So if they have this, that means the manager who's sitting in his office in, like he can see all the facility. He can tell, oh, we have low inventory from this. We have that much inventory from the Z405, for example, okay? When there is visual, that's what we call visual contact. The user removes the standard size container of part from small storage area as shown in this figure. Look, this is a cell here. We have Kanban. This is a work cell. You have Kanban. They have boxes, they move them, and then at the end, this is another cell. This is the finished good, Kanban, customer order, they deliver it. Okay. When the producer and user are not in visual contact, a card can be used. Otherwise, a light. There should be a visual contact or a contact in a way or another between the people who are in the manufacturing facility. Each car contains a specific quantity of parts, although multiple car systems may be used if there are several components, if the lot size is different from the move size. Kanban cards provide direct control and limit on the amount of work. Okay, let's learn now. Need to know how many Kanbans you need, the number of Kanbans or Kanban cards or containers I need to know the lead time needed to produce a container of parts, need to know the amount of safety stock. We talked about the safety stock, like this, Like if you have five safety stocks, so that means you have five extra. Okay, so number of Kanbans usually equal to demand during lead time plus safety stock divided by the size of the container. Okay, let's see. So a bakery bakery produces short runs of cake that are shipped to grocery stores. The owner wants to try to reduce inventory by changing to Kanban system. You know now what's Kanban system. You just get or make what you need when you need. That's it. Don't make too much. Okay. He has developed the following data and asked you to finish the project having determined that the EOQ size. See, we have the EOQ. And we then determine the number of Kanban's containers needed. The daily demand, we know, 500 cakes. The production lead time is 2 days. So the safety stock is 1/2 day. Again, so when you have the safety stock in days, okay, and the lead time in days, when you put stuff like items in one equation here, you need to change them to the same unit. Like, let's say, oh, I gave you a computer and $10. How much I gave you? You cannot say $10 and computer. You need to change them to one unit. Even to change the dollars to computer or to change the computer to dollar. So here we need to change the days to dollar or to parts. Okay. So the lead time, it says 2 days. Don't use the lead time as 2 days and plug it in the equation 2 here. No, you cannot, because you have safety stock here. It is parts, okay? And you have size of, you have cakes. You are dealing with cakes or parts. So the 2 days times 500 cakes, so the demand is 1,000 cake. Okay, I change from days to parts, okay, or in this case, number of cakes. The safety stock half day, which means 250 cakes. So now the safety stock plus the daily demand or during the lead time, 1,250 divided by 250. So the number of Kanbans is 5. That's how I get the number of Kanbans. Okay. Any questions?
No question.
Okay. Is it clear? You know now how to calculate the number of Kanbans, right? And we know how to calculate the setup time. So the number of Kanbans here is 5. So this is another example. I think this is a quiz I gave to students once. We have the daily demand 600 cakes, production lead time 3 days, safety stock half day, container size is 270. So we need to calculate the number of Kanbans again. So we take the lead time 3 times 600. Plus the safety stock 1/2 day, half times 600 divided by 270. So 1,800 plus 300 divided by 270. 1800 plus 300 divided by 270, 7.7. Okay, so we have 7.7. These are the advantages of Kanban. Of course, you save money, reduce waste. Small containers require less smooth operation, less variability. Okay, these are some lean techniques. Use statistical process control, expose poor quality. Yeah, this is just a YouTube video. Let's watch. Okay, good. So Toyota Production System continuous improvement. Build an organization culture and value system that stresses improvement for all processes. Kaizen, Kanban. Okay, respect for people. People are treated as knowledge workers. Empower employees. Standardized work. Work shall be completely specified as to content, sequence, timing, and outcome. Material and service flows must be simple and directly linked to the people or machinery involved. Okay. Let's Toyota Production System processes and standards work practice stopping production because of defects. It's called Jidoka. Let's watch also this video, short video.
Professor, I don't know if we could maybe
So for sometimes, like some cars, for example, I'm giving another example of Jidoka. Like when you drive the car, if the engine is overheated, the car will stop right away. This is Jidoka. So the car will stop, so you will not burn the engine because it's overheated for some reason. Okay, if something wrong sometimes with, for example, the same thing with the laptop or computer, sometimes this is Jidoka. Okay, this is another example, a simple example of, so stopping production because of defect. Education and training of employees, as we mentioned, always like education and training and cross training also. Understanding the customer and customer expectations. So customer expectation. So what do the customer expect from you? There are like some expectations, like the customer expect that when they come up with a new iPhone, for example, that the battery will last like 1 week. This is the expectation, for example. Functional areas communicate and collaborate to make sure customer, that's the goal, is to meet the customer expectation. Lean systems tend to have the following attribute: respect, empower, develop, work flexibility, develop collaboration, eliminate waste. That's the most important item. Two sides of the same coin when we say lean sustainability. Maximize resource use and economic. So in sustainability, we are trying to use less material. We are trying to reduce the carbon footprint for the product. So that means we are trying to reduce the waste or eliminate the waste, which includes water, all natural resources, energy, raw material. So both are two sides of the same coin. Focus on issues outside of immediate firm. Driving out waste is the common ground, as we mentioned. The lean techniques used in manufacturing and service everywhere. As I told you, we had once a project in emergency room. We were invited to, me and students, to improve the use of the toolbox for a hospital. They use that toolbox in a surgery, so we redesigned it for them. So suppliers, layout, it's everywhere. You can, in banks, in restaurants. Let me see, what's this? Okay, that's enough. So, again, let me remind you, keep here. Let me go back to the class website again. Test 2. The test will be available online next week during the class time. Make sure you take the test during that time, okay? So our meeting next week. So during the test will be online, so we don't have meeting. But on Thursday also, let's meet with Zoom next week. So on Thursday, we'll do Zoom. Because today we went to the class and again, the computer was not working. So we don't want to waste your time. And I see more students attending. We had like 20 students today attended the meeting. And if you have any questions, if you need help with before when you study for the test, let me know, okay?
Okay, thank you, Professor.
Any questions? Okay,
No.
thank you. Thank you.
Have a good one.
You too. Bye.
Thanks, Professor. Have a good day.
You too. Thank
Oh,
you.
I have a question. I'm sorry.
Yeah.
Where do I find the Zoom recording?
I usually put the recordings on the class website. So look here, for example, last week, not last week. Yeah, see, I put it here.
Okay, cool.
So you need to go to the home page and then course material. And then, so for example, today we had a meeting. I'm going to put it here.
Okay.
Okay. Oh, we had one before, but I will put this here. Okay.
Thank you.
Thank you.